Welcome to Lab 3. In the following problem, a star is orbiting a black hole of unknown mass. Assume the net force on the system is due solely to the gravitational force of the black hole. Using the results of your analysis, estimate the mass of the black hole. Here's my code in Python. Here we set the range. The range is a scale of the screen. I set it slightly larger than the radius of the orbit. Here we create the star, and I made my star blue. The radius of the star is an arbitrary value just for visualization. I set the background color to black just to make the presentation cooler, and have a origin shadow or black hole shadow of white, and the black hole is black, obviously. In real life you cannot see black holes. Here's the mass of the star and delta t given in the assignment. Here we compute all of the x and y velocities and put them into lists. This is our main loop. Each time through the loop we calculate the initial velocity and the final velocity, one step, and then multiply those by the star's mass to get the momentum vectors. Then we calculate delta V and delta P by subtracting the final and initial values. Fnet is just equal to delta P divided by delta T because there are no other forces on the object other than the momentum. Here we have the change in the magnitude of delta P over delta T, and delta P over delta T parallel is the change in the magnitude times P hat. Fnet parallel is the same as delta P over delta T parallel because delta P over delta T is the only force acting upon the star in this scenario. We find delta P over delta T perpendicular by subtracting delta P over delta T by delta P over delta T parallel. And the same goes for Fnet perpendicular as for Fnet parallel. This is where we update the position of the star by the data we got in a CSV file. Before the main loop, I set the universal gravitational constant and an average mass of the black hole. The equation for finding the mass of the black hole is derived from the equation for finding the gravity Fnet on the star. Every iteration through the loop, we add the current mass of the black hole to the overall mass of the black hole using our equation. And then at the end of the loop, we calculate the average mass of the black hole by dividing by the number of iterations in the loop. And here's the mass of the black hole. In your analysis, you should discuss how Fnet perpendicular and Fnet parallel are different from delta P over delta T parallel and delta P over delta T perpendicular. Delta P over delta T is the observation of the motion, where Fnet is the actual force on the star. In our project, we are given the positions of the star, and we can find delta P over delta T, and we understand that that is the same as Fnet in this particular case because there are no other forces acting on the star. What if the black hole whose mass you found was replaced by a different black hole but still placed at the same location. Assume the motion of the observed star remains unchanged and is affected only by the gravitational force of the new black hole. Could you tell the difference? The only way you would be able to find a different mass for the black hole is if you had a different mass for the star. As long as the motion and mass of the star stays the same, the mass of the black hole should also stay the same. Thank you for watching my Lab 3 video.